Did you know that Voyager 1 is currently traveling at 38,000 miles per hour through interstellar space, yet it would still take over 73,000 years to reach the nearest star? This incredible spacecraft has been humanity's most distant messenger for decades, sending back data from the edge of our solar system, where no human-made object has ever ventured before. But here's the mind-blowing part. It just detected something moving out there that's completely rewriting the rules of space exploration. Do you know what could possibly be lurking in the cosmic void that caught Voyager's attention? The mysterious detection. What if I told you that humanity's most distant messenger just stumbled upon something that's rewriting the rules of space exploration? Voyager's instruments suddenly lit up like a Christmas tree when they detected an anomalous signal showing something in motion far beyond our solar system's boundaries. This wasn't your typical space rock drifting aimlessly through the void. The object wasn't following any predictable orbital pattern that planets are known for, and its movement seemed almost deliberately erratic. Scientists initially dismissed it as a potential glitch in the decades-old equipment, but when multiple readings kept confirming the same impossible data, they realized something extraordinary was actually out there. The object appeared to be moving in ways that completely defied conventional astronomical expectations, accelerating and decelerating at seemingly random intervals, as if it possessed some form of intelligence or control system. What made this discovery even more mind-bending was that the movement patterns were so unusual that astronomers had to throw out their existing tracking models and create entirely new ones just to follow its trajectory through the cosmic darkness. The readings suggested this mysterious entity was operating under principles that our current understanding of physics couldn't easily explain, leaving the scientific community both thrilled and deeply unsettled by the implications of what Voyager had accidentally discovered in the furthest reaches of known space. Beyond planetary motion. You know what separates a wandering space rock from something that might actually be intelligent? The way it moves? This wasn't your typical celestial body behavior that astronomers study in textbooks. We're talking about something that completely broke the fundamental rules of how objects are supposed to move through space. While planets follow those predictable elliptical orbits around stars that we've mapped for centuries, this mysterious object was dancing to its own cosmic rhythm, moving in patterns that seemed to mock our understanding of orbital mechanics. The really spine-chilling part? It appeared to accelerate and decelerate at what seemed like random intervals, almost as if something was making conscious decisions about where to go next. Scientists watching the data streams felt like they were observing a chess player making calculated moves, rather than a lifeless chunk of matter drifting through the void. The movement patterns were so fundamentally different from anything in our astronomical databases that researchers had to abandon decades of established tracking protocols and develop completely new mathematical models just to predict where this thing might go next. What kept everyone awake at night was the unsettling realization that this object seemed to possess some form of propulsion or guidance system that operated independently of any known gravitational influences, suggesting either revolutionary physics at work or something far more extraordinary than anyone was prepared to admit publicly. Instrument readings gone wild. When a machine built in the 1970s starts detecting signals that don't exist in any modern database, you know something's seriously wrong. Voyager's magnetometer and plasma wave instruments began registering readings that sent shockwaves through mission control, displaying data patterns that didn't match a single entry in their comprehensive astronomical databases. The object appeared to be generating its own electromagnetic field, which is incredibly rare for natural space objects and typically only seen in active stars or massive planetary bodies with molten cores. Even more bizarre, the readings suggested this mysterious entity might be rotating or tumbling in a highly complex pattern that created interference signatures unlike anything scientists had previously encountered from asteroids, comets, or typical space debris. The electromagnetic emissions were so unusual that they seemed to pulse in rhythmic intervals, almost like a heartbeat echoing through the vacuum of space. What made the situation even more unsettling was that these readings were coming from instruments that had been functioning flawlessly for decades, suddenly encountering phenomena that their creators never anticipated when designing the detection systems back on Earth. The data streams showed energy signatures that fluctuated in ways that suggested either some form of internal power source or an interaction with unknown cosmic forces that current physics couldn't adequately explain. mission scientists found themselves staring at computer screens, displaying information that challenged everything they thought they knew about how objects behave in the cold emptiness of interstellar space, leaving them questioning whether they were witnessing a natural phenomenon or something far more extraordinary. The rogue object theory. So, what happens when scientists discover something that's, too small to be a planet but way too active to be just dead rock? Well, at first scientists thought maybe this could be a rogue planet, one of those lonely worlds that gets ejected from its original solar system and ends up wandering through the infinite darkness of interstellar space, sort of like a cosmic exile. These planetary outcasts are known to drift aimlessly through the void after getting gravitationally kicked out of their home systems by larger planets or big stellar events. But the size readings from Voyager's instruments just didn't match up with what you'd expect from a typical rogue planet. And even more puzzling, rogue planets don't usually move with such unpredictable and honestly almost purposeful patterns. They tend to follow predictable trajectories influenced by the gravitational pull of nearby massive objects. But this mysterious entity seemed too small to qualify as a planet, yet it was far too large and energetically active to be classified as your typical space debris or asteroid material floating through the cosmic wasteland. What really threw researchers off was the object's apparent ability to change direction and speed without any obvious external gravitational influences acting on it. That kind of behavior totally contradicted everything scientists thought they knew about how rogue planets should behave out in the emptiness between star systems. The data pointed to something that existed in this strange middle ground between planetary and non-planetary classifications, leaving the scientific community with, way more questions than answers about its true nature and origin. This discovery really forced astronomers to rethink their basic understanding of what makes a planetary body, and whether there might be entirely new categories of cosmic objects drifting through space that just don't fit into our current classification systems. Artificial origin speculation. The moment scientists started whispering about artificial intelligence in deep space, everything changed. Here's where the discovery really took a turn and made even the most skeptical researchers pause and rethink everything they thought they knew about our cosmic neighborhood. Some scientists began seriously wondering if this mysterious object could actually be artificial in origin, a possibility that sent ripples of both excitement and, honestly, a bit of terror through the astronomical community. The object's highly unusual movement patterns, those distinctive electromagnetic signatures, and its apparent ability to change direction without any obvious external forces, led to these hushed conversations about possible extraterrestrial technology drifting out there in the void. Now, while most established researchers stayed publicly skeptical and didn't want to jump to such extraordinary conclusions, the data piling up was compelling enough that even the most conservative astronomers couldn't completely dismiss the possibility of an artificial probe or spacecraft from another civilization. What made this theory so unsettling was that the object seemed to actually show behaviors that matched up with some kind of guidance system or onboard intelligence, responding to unknown stimuli in ways that natural space objects just don't. The electromagnetic pulses appeared almost like communication attempts or maybe diagnostic signals, suggesting internal systems that could be actively monitoring or scanning the surrounding space environment. All this speculation opened up some mind-bending questions about whether humanity had just stumbled across evidence of advanced alien technology, possibly an automated probe sent by a distant civilization to explore our neck of the galaxy. That would fundamentally challenge our understanding of whether we're truly alone in the universe, and what other intelligences might be silently watching us from the darkness of space. Comet or something else? So, when something behaves like a comet but breaks just about every rule about how comets are supposed to work, you've really got a cosmic mystery on your hands. The next theory that popped up from all the scientific chaos focused on whether this enigmatic object could some kind of unusual comet with a highly irregular orbit. But even this seemingly logical explanation started to fall apart under closer scrutiny. Comets are notorious for their unpredictable behavior, especially when they interact with solar winds and the gravitational fields from massive celestial bodies. That's what creates those spectacular tails and erratic flight paths that can confuse even the most experienced astronomers. However, this mysterious object was positioned way too far from any star to show the typical comet behavior that scientists have documented for centuries. It was operating in the cold vacuum of interstellar space, where solar radiation really shouldn't have much impact on its structure or movement patterns. What made the comet theory even more unlikely was that the object's movement seemed totally independent of any detectable gravitational influence from nearby stellar bodies. That kind of thing suggests it had some form of internal propulsion system, rather than just relying on external cosmic forces. Traditional comets follow predictable physics when they get close to heat sources, developing those characteristic tails and accelerating in ways that match established mathematical models. But this object just didn't fit those expectations at all. The electromagnetic readings and those weird directional changes happened without any connection to solar activity or gravitational wells, which indicated that whatever this thing was, it operated under principles that had nothing to do with the usual ice and rock composition that defines comets. That left researchers seriously wondering if they were dealing with something that was just pretending to be a familiar cosmic phenomenon. Interstellar visitor analysis. Sometimes, the most terrifying discoveries are the ones that remind us we're not alone in this cosmic neighborhood. Data analysis revealed this object might be an interstellar visitor, something that originated outside our solar system and was just passing through our cosmic backyard like an uninvited guest. Similar to Oumuamua, the mysterious cigar-shaped object that briefly visited us back in 2017 and left scientists scrambling for explanations, this new detection showed unmistakable characteristics of something that definitely didn't belong to our familiar solar system family. However, unlike Oumuamua, which seemed to drift through space following predictable physics, this object appeared to be actively maneuvering rather than just coasting on momentum from its original trajectory. The spectral analysis suggested it carried chemical signatures completely foreign to anything found in our local planetary formation, indicating it had traveled unimaginable distances through the void between star systems before somehow ending up in Voyager's detection range. What made this discovery particularly spine-chilling was the realization that if this was indeed an interstellar traveler, it meant our solar system was being visited by objects from distant cosmic regions, with potentially different physical laws or evolutionary histories. The object's ability to maintain apparent control over its movement after what must have been millions of years of interstellar travel suggested either incredibly advanced preservation technology or something that, honestly, challenged our understanding of how matter behaves across vast cosmic distances. This raised unsettling questions about what other mysterious visitors might be silently passing through our solar system without our knowledge, observing us from the darkness. Scientific community divided. Nothing splits the scientific world faster than a discovery that challenges everything we thought we knew about reality. The discovery created a massive rift that split the scientific community into warring factions, each defending their interpretation of the data with the passion of religious zealots. Conservative astronomers dug in their heels, insisting this must be a natural phenomenon they simply hadn't encountered before, arguing that extraordinary claims require extraordinary evidence and that jumping to wild conclusions would damage their professional credibility. Meanwhile, a growing faction of researchers argued that the mounting evidence pointed to something far more extraordinary than conventional wisdom could accept, suggesting that clinging to outdated assumptions was preventing genuine scientific progress. Peer review processes transformed into heated battlegrounds where respected colleagues found themselves shouting across conference rooms, with researchers demanding more comprehensive data before making any definitive conclusions about the object's true nature and origin. The tension became so intense that some scientists refused to collaborate with colleagues who held opposing views, creating an unprecedented schism in a field that typically thrives on cooperative research and shared discoveries. What made this division particularly bitter was that both sides were working with the same limited dataset from Voyager's aging instruments, yet reaching completely different conclusions about what they were observing in the depths of space. The controversy exposed deep philosophical differences about how science should approach unexplained phenomena, with traditionalists advocating caution, while progressives pushed for bold new theories that could revolutionize our understanding of the cosmos and humanity's place within it. Technology limitations. When your most advanced space probe is running on technology older than most smartphones, getting answers becomes nearly impossible. Unfortunately, Voyager's aging instruments and vast distance from Earth meant the data was frustratingly limited and sometimes contradictory, like trying to solve a murder mystery with a broken magnifying glass. The spacecraft's communication systems, originally designed in the 1970s using technology that would seem primitive compared to a modern calculator, struggled desperately to transmit detailed information about this unprecedented discovery across the mind-boggling distances of interstellar space. Scientists found themselves in the maddening position of having to work with incomplete datasets that arrived months after being recorded, making it incredibly challenging to determine exactly what Voyager had encountered in the cosmic depths. The probe's instruments were never designed to analyze the type of anomalous readings they were now detecting, forcing researchers to extrapolate conclusions from equipment that was already operating far beyond its intended lifespan and capabilities. Signal degradation across billions of miles meant that crucial details about the object's behavior were lost in transmission, leaving tantalizing gaps in the data that could have provided definitive answers about its nature and origin. What made this situation even more frustrating was that by the time scientists received and analyzed the information, the mysterious object had often moved to a completely different location, making follow-up observations nearly impossible. The technological limitations created a perfect storm of scientific frustration, where humanity's most distant explorer had discovered something potentially revolutionary, but lacked the tools to properly study it. Ongoing mystery. Some mysteries are so profound that they redefine what we thought was possible in the universe. As of now, the object remains one of space exploration's greatest unsolved mysteries, a cosmic riddle that continues to haunt scientists and challenge our fundamental understanding of what exists in the vast emptiness between stars. Voyager continues to track its movement when possible, but the object's unpredictable behavior makes consistent observation feel like trying to photograph a ghost that appears and disappears at will. The enigmatic entity seems to operate under its own mysterious agenda, sometimes vanishing from detection for weeks before reappearing in completely unexpected locations, as if it's deliberately evading our attempts to study it. Future deep space missions are being frantically planned with more advanced instruments specifically designed to investigate similar anomalies, but the reality is that we're still years away from having the technology capable of properly analyzing whatever this thing actually is. For now, we're left in the uncomfortable position of knowing something extraordinary is out there, moving through the cosmic void with apparent intelligence or purpose, while being completely powerless to determine its true nature or intentions. The discovery has fundamentally altered how scientists approach the search for unusual phenomena in space, forcing them to acknowledge that our universe might be far stranger and more populated than we ever dared to imagine. This mysterious object serves as a humbling reminder that despite all our technological advances and scientific achievements, we're still cosmic children stumbling around in the dark, occasionally bumping into things that shouldn't exist according to our current understanding of reality. So what do you think we're dealing with here? A natural phenomenon we've never encountered before, or something that challenges our understanding of what's possible in deep space? The fact that Voyager can still surprise us with discoveries like this just shows how much we still don't know about our universe. Drop a comment below and let me know your theory about this mysterious moving object. I read every single one. If this blew your mind, smash that subscribe button and hit the bell icon so you never miss when Space Facts drops new content. Until next time, keep looking up. A seismic signal from the moon has just sent shockwaves through the scientific world, and Michio Kaku isn't mincing words. He's calling it a wake-up call for humanity. Kaku warns that this unexpected tremor could mean the moon's core isn't as dormant as we once believed, raising the stakes for both lunar science and life on Earth. Did you know the moon's gravitational pull actually helps stabilize Earth's climate and tides? If the moon is changing, so could our world. Here's a question. Did you know the moon's core might still be active? Seismic signal discovery. A seismic signal on the moon has just thrown the scientific world into a frenzy, and Michio Kaku isn't holding back his concerns. This isn't your average moonquake. This signal was so unexpected and intense that it's forcing scientists to rethink what's happening deep beneath the lunar surface. Kaku, a leading voice in theoretical physics, jumped into the conversation, warning that the moon's core might not be as dormant as we once believed. He explained that for decades, experts assumed the moon was geologically dead, but this seismic activity hints at a mysterious force stirring within. The implications go far beyond curiosity. The moon's core plays a crucial role in stabilizing Earth's tilt and controlling our tides. If something is shifting inside the moon, Kaku warns, it could have ripple effects right here on Earth. Subtle changes in our tides, maybe even our weather. What's even more fascinating is that this seismic event doesn't fit the usual patterns caused by meteor strikes or temperature changes. Thanks to advanced sensors from recent lunar missions, scientists are now picking up signals that were invisible during the Apollo era. Kaku's message is urgent. We're standing at the edge of a new era in lunar science and we need to pay attention. As researchers scramble to decode the moon's signals, one thing is clear: our closest neighbor is keeping secrets, and those secrets might be more important than we ever imagined. Michio Kaku's immediate reaction. When news broke that Michio Kaku had responded to the moon's seismic signal, curiosity skyrocketed across the globe. Kaku's immediate reaction was far from casual. He called the event a wake-up call for scientists everywhere. He emphasized that this wasn't just another blip in lunar data, it could be the first sign of a deeper transformation inside the moon. Kaku's words carried weight, especially as he explained that such seismic activity might point to an awakening of the lunar core, a region long thought to be frozen in time. He urged the scientific community not to underestimate the importance of this signal, warning that ignoring it could mean missing out on a fundamental shift in our understanding of the moon. According to Kaku, the rarity of this event is precisely what makes it so alarming. He drew attention to the fact that our technology has finally reached a point where these subtle signals can be detected and analyzed in real time, making this discovery even more significant. Kaku's passionate call for vigilance resonated with those who understand the interconnectedness of celestial bodies. He made it clear that the moon's fate is tied to Earth's in ways we're only beginning to grasp. As his warning echoes through the halls of science, the world is left to wonder, what else is lurking beneath the surface of our lunar companion, and are we truly prepared for the answers that might emerge? Why the moon's core matters. Beneath the moon's familiar glow, a hidden drama is unfolding that could rewrite everything we thought we knew about our cosmic neighbor. For decades, scientists assumed the moon's core was cold, still, and unchanging, a relic of ancient times. Now, Michio Kaku is sounding the alarm, arguing that the core's activity could be far more dynamic than anyone expected. He highlights how the moon's core, though small compared to Earth's, plays a vital role in shaping the lunar magnetic field and, by extension, the environment that shields the moon from solar radiation. Kaku warns that if the core is indeed waking up, we might see changes in the moon's magnetic properties, which could even affect future lunar missions and technology placed on its surface. The idea that the moon is still evolving deep beneath its crust challenges the long-held belief that it's a geologically dead world. Kaku's insights push us to reconsider the moon's entire history and its ongoing influence on Earth. He suggests that understanding these core processes isn't just an academic exercise, it's essential for predicting how the moon will behave in the future. As seismic signals continue to surface, the scientific community is left with a pressing question. Are we witnessing the rebirth of lunar activity, and what does that mean for humanity's next steps in space exploration? The moon's core, once thought silent, may be trying to tell us a story that's only just beginning to unfold. Potential impacts on Earth. Every so often, a discovery comes along that challenges the very foundation of what we think we know about our place in the universe. Michio Kaku is quick to point out that the moon's core isn't just a scientific curiosity, it's a critical piece of the puzzle that keeps Earth's delicate balance in check. The gravitational pull between the Earth and Moon does more than create tides, it actually helps stabilize our planet's axial tilt, which in turn keeps our seasons predictable and our climate relatively steady. If seismic signals are hinting at changes deep within the Moon, Kaku warns that even subtle shifts could have far-reaching consequences for life on Earth. He explains that a more active lunar core might alter the gravitational relationship between our two worlds, potentially affecting everything from ocean currents to weather patterns. This isn't just a concern for astronomers or geologists, it's a wake-up call for anyone who depends on Earth's natural rhythms, which is, well, all of us. Kaku's message is clear: we can't afford to ignore the moon's signals or assume that its influence ends at the edge of its cratered surface. As scientists race to decode what's really happening beneath the lunar crust, the rest of us are left to wonder how the moon's hidden changes might ripple through our own lives, subtly shaping the world in ways we're only beginning to understand. Historical context. A single seismic signal has upended decades of lunar research, leaving experts scrambling for answers. Michio Kaku draws attention to how past theories about the moon's seismic activity were largely shaped by meteor impacts or the slow cooling of its crust. But this new signal doesn't fit the old script. It arrived with a force and frequency that defies the usual explanations, hinting at processes deep inside the moon that scientists never anticipated. Kaku emphasizes that historically, moonquakes were thought to be rare and easily explained by external events. Now with this unexpected tremor, the scientific community is forced to consider the possibility of an active, evolving core. What's truly captivating is how this event challenges established models of lunar geology. Kaku's warning is that we may have underestimated the complexity of the moon's inner workings all along. The seismic anomaly stands as a stark reminder that even our closest celestial neighbor holds mysteries capable of shaking the foundations of planetary science. As researchers pore over the data, they're left to confront the uncomfortable truth that the moon's story is far from complete. The old assumptions are crumbling, and in their place is a new sense of urgency to understand what's really happening beneath the surface. For anyone fascinated by the unknown, this seismic event is proof that the universe still has plenty of surprises in store. Advanced detection technology. Lunar exploration has entered a new era, thanks to technology that's more sensitive than anything used during the Apollo missions. Michio Kaku highlights how recent advances in seismic detection have pulled back the curtain on the moon's hidden activity, capturing signals that would have gone unnoticed just a decade ago. These new instruments, deployed by international teams and robotic landers, can pick up the faintest tremors from deep within the lunar core. Kaku points out that this leap in technology is a game-changer. For the first time, scientists can monitor the moon's interior in real time, tracking shifts and pulses that reveal its true nature. The seismic signal that sparked Kaku's warning was detected by this new generation of sensors, offering a level of detail that's rewriting the textbooks. It's not just about spotting moonquakes, it's about understanding the moon's ongoing evolution and the forces shaping its future. Kaku stresses that these tools are opening a window into a world that, until now, was shrouded in mystery. The data pouring in is challenging assumptions and pushing scientists to ask bigger, bolder questions about what lies beneath the surface. As the technology continues to improve, Kaku believes we're on the brink of discoveries that could redefine our relationship with the moon, and by extension, our own planet's place in the cosmos. Unanswered questions. A single seismic signal has left scientists with more questions than answers, and Michio Kaku isn't shy about what's at stake. He underscores how little we truly know about the moon's interior despite decades of exploration and countless missions. The recent tremor has exposed a glaring gap in our understanding, forcing experts to reconsider long-held beliefs about lunar geology. Kaku emphasizes that this isn't just an isolated event, it could be the tip of the iceberg, a clue to a pattern of activity that's been hidden for millennia. He challenges the scientific community to confront the unknown head-on, urging deeper investigation and open-minded analysis. Theories are swirling. Could this signal be tied to ancient volcanic processes, or does it hint at something entirely new beneath the crust? Kaku's message is clear. Science thrives on curiosity and the courage to question. He warns against complacency, reminding us that every breakthrough starts with a mystery that refuses to be ignored. As researchers sift through the data, the sense of urgency grows. The moon, once thought to be a silent witness to cosmic history, may be far more dynamic and unpredictable than anyone imagined. Kaku's call to action is resonating across the globe, inspiring a new generation of scientists to dig deeper and listen closer to the stories written in the moon's seismic whispers. Theories and speculation. A seismic mystery on the moon has triggered a wave of speculation among scientists, and Michio Kaku is urging everyone to keep their minds open. Instead of jumping to conclusions, he highlights the need for careful analysis and a willingness to embrace the unknown. Some experts are already floating theories that this signal could be linked to ancient volcanic activity, hinting at a past where the moon was far more alive than we ever imagined. Others suggest it might be the result of the moon's gradual cooling and contraction, processes that could still be shaping its core today. Kaku cautions against settling on easy answers, reminding us that true scientific progress comes from questioning, testing, and sometimes overturning what we think we know. He points out that every seismic anomaly is a chance to uncover new layers of lunar history, clues that could reshape our understanding of how the moon, and even the Earth, evolved. The excitement is palpable as researchers debate the possibilities, knowing that each new discovery brings us closer to solving the riddle of our celestial neighbor. Kaku's call for patience and rigor is a rallying cry for scientists everywhere. Don't just look for what you expect to find, be ready for the unexpected. In this moment of uncertainty, the moon is offering up secrets that could rewrite the story of our solar system, and Kaku wants to make sure we're paying attention to every detail. Call for international collaboration. Global cooperation is suddenly in the spotlight as Michio Kaku calls for a united scientific front in response to the moon's seismic surprise. He's not content with isolated discoveries or fragmented research. Kaku insists that only by pooling resources, data, and expertise can humanity unlock the true meaning behind these mysterious signals. This isn't just a challenge for one nation or a handful of space agencies, it's an invitation for the world to work together on a cosmic puzzle that could affect us all. Kaku envisions international teams sharing seismic data in real time, cross-analyzing findings, and launching joint missions to deploy even more advanced sensors on the lunar surface. He argues that collaboration is the fastest path to breakthroughs, and that the moon's secrets are too important to be kept behind national borders. The urgency in his voice is unmistakable. If the moon's core is changing, the stakes are global, and so must be our response. Kaku's rallying cry is already inspiring new partnerships and conversations among scientists who might otherwise have worked in silos. As the world tunes in to this unfolding lunar mystery, the message is clear. The universe doesn't care about boundaries, and neither should our search for answers. In this new era of space exploration, Kaku's vision of global teamwork could be the key to understanding the moon and safeguarding our future on Earth. What's next for lunar science? A new chapter in lunar science is unfolding, and Michio Kaku believes the next steps could redefine our relationship with the moon forever. He's pushing for more than just analysis. He wants action. Kaku urges the scientific community to accelerate plans for deploying even more advanced sensors and robotic explorers to the lunar surface, arguing that only with a constant stream of real-time data can we truly monitor the moon's evolving core. He envisions a future where lunar bases double as seismic observatories, feeding information directly to researchers on Earth and enabling instant responses to any new tremors or anomalies. This isn't just about satisfying curiosity. Kaku warns that understanding the moon's inner workings could be critical for the safety of future astronauts, the protection of lunar infrastructure, and even the stability of Earth itself. The recent seismic event is a wake-up call, and Kaku's message is clear. The moon is alive with secrets, and it's up to us to listen. As new missions are planned and international collaborations take shape, the excitement is palpable. Each new sensor, rover, and data stream brings us closer to unraveling the mysteries beneath the moon's surface. For Kaku, this is more than science. It's a race to secure our place in the cosmos, armed with knowledge and united by a shared sense of wonder and responsibility. Thanks for joining me on this deep dive into the mysteries of the moon. If you found these insights as fascinating as I did, don't forget to subscribe to Space Facts for more mind-blowing discoveries from across the universe. Hit that bell icon so you never miss an update, and let me know your thoughts or questions in the comments below. Your curiosity keeps this community thriving, so keep those ideas coming. Until next time, stay curious and keep looking up. Intro. Right now, 400 million miles from Earth, a storm larger than our entire planet has been raging for over 350 years, longer than the United States has existed. The Great Red Spot on Jupiter generates winds of 400 miles per hour that could obliterate everything in their path. Yet this cosmic hurricane maintains perfect stability in an environment of absolute chaos. But here's the terrifying truth. This ancient storm is dying, shrinking at 580 miles per year, and when it finally disappears, Jupiter will never be the same again. Did you know that we're literally watching the death of a weather system older than human civilization unfold in real time? The mystery storm discovery. When Juno reached Jupiter's North Pole in July 2016, mission control went dead silent. What they saw defied every computer model, every prediction, every theory about gas giant atmospheres. 8 massive cyclones, each the size of Texas, were arranged in a perfect geometric pattern around a central hurricane that could swallow Earth whole. These weren't ordinary storms. They were maintaining positions with mathematical precision that seemed almost artificial. The southern pole revealed an equally bizarre sight: 6 cyclones locked in a pentagonal formation, spinning at 100 miles per hour while staying 52 degrees Fahrenheit cooler than their surroundings. What terrified scientists most was the stability. On Earth, hurricanes last days or weeks before dissipating. These Jovian monsters have been maintaining their cosmic dance for years, possibly centuries. The Deep Space Network tracking data showed these cyclones weren't just surface features. They were connected to atmospheric rivers flowing thousands of miles deep. It's as if Jupiter operates by entirely different laws of physics, where chaos organizes itself into patterns that shouldn't exist according to everything we understand about planetary atmospheres. Largest eruption recording. The microwave radiometer aboard Juno penetrated deeper into Jupiter than any instrument ever had, and what it found was absolutely mind-bending. Hidden beneath the cloud tops were towering atmospheric structures that scientists dubbed steeple mountains. Invisible giants of gas and energy extending 1,800 miles down into the planet's interior. To comprehend this scale, that's 270 times deeper than Earth's Mariana Trench. These weren't physical mountains but massive atmospheric belts that plunge into Jupiter's core like cosmic elevator shafts. The gravitational measurements from Juno's 54th flyby on September 7, 2003 revealed the shocking truth. Jupiter's atmosphere doesn't end where we thought it did. Instead, it blends seamlessly with the planet's interior in a way that violates our basic understanding of planetary structure. The spacecraft used Jupiter's own gravity as a scanning tool, measuring velocity changes as small as 0.01 millimeter per second from over 400 million miles away. What emerged was a 3-dimensional map of a world where the boundary between atmosphere and interior simply doesn't exist. Jupiter isn't just a gas giant with a solid core, it's a fluid, chaotic system where atmospheric storms reach depths that would take you from New York to the center of Earth and back again. Largest eruption recording. Juno uncovered evidence of atmospheric eruptions so massive they make Earth's most violent volcanic explosions look like firecracker pops. The Great Red Spot, that iconic crimson hurricane we've admired for centuries, plunges an astounding 300 miles below the cloud surface, deeper than the distance from Earth to the International Space Station. But this ancient storm, observed since the mid-1600s, is just one player in a symphony of atmospheric violence. Smaller storms reach 60 miles down, while others extend over 200 miles into Jupiter's interior, creating a labyrinthine network of atmospheric chaos that operates in 3 dimensions. The energy scales involved are beyond human comprehension. These storms have been raging for millennia, powered by forces that dwarf anything in our solar system. NASA's precision instruments detected atmospheric explosions that release more energy in a single event than Earth receives from the Sun in an entire year. The Deep Space Network measured these eruptions with incredible accuracy, revealing that Jupiter's weather system isn't just more violent than Earth's, it operates on completely different principles. While our storms are temporary disturbances in a stable atmosphere, Jupiter's storms are permanent features of a world in constant atmospheric rebellion against the laws of physics as we understand them. Jupiter's magnetic field. The magnetometer investigation aboard Juno revealed that Jupiter's magnetic field is not just stronger than expected, it's completely alien in structure. Jack Connerny from NASA's Goddard Space Flight Center led the team that created the most detailed magnetic map ever made of another planet, using data from 32 orbits around the gas giant. What they discovered was terrifying. A magnetic field more than twice as powerful as models predicted, with an irregular, chaotic structure unlike anything seen before. The most unsettling discovery was the Great Blue Spot, a massive magnetic anomaly at Jupiter's equator that's drifting eastward at 2 inches per second, completing a full lap around the planet every 350 years. This isn't just a magnetic field, it's a cosmic scar. Scientists believe meteorite impacts billions of years ago modified Jupiter's magnetic structure, which is now frozen in a superconducting core, like a permanent record of ancient cosmic violence. Even more disturbing is the discovery of secular variation. The magnetic field is changing over time, something previously only detected on Earth. Jupiter carries the magnetic memory of collisions that happened when the solar system was young and chaotic, making the planet a living museum of cosmic catastrophes that shaped the worlds we see today. Atmospheric water mystery. Juno's microwave radiometer has been conducting the ultimate planetary autopsy, using 6 antennas to X-ray hundreds of kilometers below Jupiter's cloud tops. And what it's finding about water content is rewriting the textbooks on planetary formation. For decades, scientists assumed Jupiter formed beyond the frost line where water should freeze and accumulate in massive quantities. The planet should be soaked with water vapor, but Juno's measurements are revealing a distribution so patchy and unpredictable that it's forcing us to reconsider everything about how gas giants form. The water mystery cuts to the heart of solar system formation theory. If Jupiter's water content doesn't match our models, it suggests the early solar system was far more violent and chaotic than we ever imagined. The implications are staggering. It could mean that planets don't grow peacefully by accumulating material, but are forged in cosmic disasters that fundamentally alter their composition. Juno's deep atmospheric scans are essentially performing cosmic archaeology, peering into Jupiter's interior to read the story of its formation, written in water vapor concentrations. What they're finding suggests that Jupiter didn't form where we think it did, or that massive collisions during its formation scattered water in ways that defy current planetary formation models. The planet is keeping secrets about the early solar system that could change our understanding of how Earth and every other world came to exist. Polar cyclone dynamics. The poles of Jupiter are cosmic madness manifested in 9 cyclones arranged in perfect geometric symmetry around the North Pole, 6 cyclones forming a pristine pentagon around the south. NASA's navigators have been tracking these atmospheric beasts with surgical precision since Juno's arrival in July 2016, and what they've discovered violates every principle of atmospheric dynamics we know. Each cyclone spans nearly the width of the continental United States, spinning at incredible velocities while maintaining their positions like cosmic clockwork. On Earth, storms are temporary chaos that forms and dissipates. But Jupiter's polar cyclones have been locked in their geometric dance for years, possibly centuries. They resist change with an almost intelligent stubbornness, forming what scientists describe as a private club that seem to resist new members. The data reveals these aren't just surface storms, they're massive atmospheric columns extending thousands of miles into Jupiter's interior, connected to the planet's deep atmospheric rivers like cosmic pillars holding up the sky. The precision of their arrangement suggests forces at work that we don't understand. Atmospheric dynamics operating on scales and timescales that make Earth's weather look like child's play. These cyclones are essentially atmospheric monuments, permanent fixtures in a world where chaos has somehow organized itself into mathematical perfection that shouldn't be possible according to everything we know about fluid dynamics and planetary atmospheres. Jupiter's composition and structure. Juno's gravitational measurements have shattered our most fundamental assumptions about Jupiter's interior structure. The spacecraft has revealed that the king of planets doesn't have a solid core like textbooks claim. Instead, it harbors a fuzzy core made of rock fragments and metallic hydrogen scattered throughout its interior like cosmic shrapnel. This discovery is revolutionary because it suggests Jupiter's formation was catastrophically violent, likely the result of a massive collision that occurred during the early solar system's chaotic youth. Juno acts like a cosmic detective, using tiny velocity changes to map the distribution of mass inside Jupiter. By measuring gravitational variations as small as 0.01 mm per second from hundreds of millions of miles away, scientists can essentially see through the planet's layers. What they're finding is that Jupiter's interior is not the neat layered structure we expected. It's a chaotic mixture where different materials are scattered in patterns that speak of ancient violence. The implications are staggering. If Jupiter was fundamentally altered by a collision, it means planetary formation in our solar system was far more destructive than we thought. Planets aren't just peaceful accumulations of cosmic dust and gas, they're the survivors of cosmic wars fought billions of years ago, carrying the scars of impacts so massive they can reshape entire worlds and alter the course of planetary evolution forever. Great Red Spot Analysis. The Great Red Spot has been Jupiter's most iconic feature since telescopes first revealed it in the mid-1600s, but Juno's close-up analysis has unveiled a storm so complex and alien that it's forcing us to redefine what we thought we knew about atmospheric phenomena. This isn't just a hurricane, it's a 300-mile-deep atmospheric monster that extends from the cloud tops down into Jupiter's interior, further than the distance from Earth's surface to the International Space Station. Juno's instruments have mapped the storm's three-dimensional structure, revealing a spiraling tower of gas and energy that operates like a cosmic tornado lying on its side. The storm's winds reach speeds that would instantly destroy anything on Earth, while temperatures and pressures at its base approach conditions found in the cores of rocky planets. What makes the Great Red Spot truly terrifying is its permanence. This storm has been raging continuously for over 400 years, possibly much longer. It's a weather system older than most human civilizations, powered by energy sources we're only beginning to understand. Juno's data reveals that the spot is connected to Jupiter's deep atmospheric layers, drawing energy from the planet's interior heat like a cosmic engine that never stops running. The storm is essentially a window into Jupiter's soul, a permanent scar in the atmosphere that reveals the violent, chaotic nature of a world where weather operates on scales and timescales that dwarf anything in human experience. Jupiter as planetary protector. Juno has documented Jupiter's role as our solar system's bodyguard in terrifying detail, revealing a cosmic protector that's constantly under siege from interplanetary debris. The spacecraft observed a meteor impact in April 2020 with an estimated mass of 250 to 5,000 kilograms, just one of countless projectiles that Jupiter's massive gravitational field captures before they can hurtle toward the inner solar system. Without this cosmic vacuum cleaner, Earth would face regular bombardment from asteroids and comets, making complex life nearly impossible. Juno's observations show that Jupiter is essentially sacrificing itself for the rest of us, taking hit after hit from space rocks while we orbit safely in the inner solar system. Each impact creates massive explosions visible from hundreds of millions of miles away, releasing energy equivalent to multiple nuclear weapons. The planet's gravitational influence extends far beyond its physical size, reaching out like invisible tentacles to snare dangerous objects that might otherwise threaten Earth. But this protection comes at a cost. Jupiter is constantly being bombarded, its atmosphere churned by impacts that would sterilize entire continents on Earth. The planet stands as a cosmic shield between us and the chaos of deep space, a guardian world that absorbs the violence of our solar system's debris-filled void. Juno's documentation of this protective role reveals that our existence might depend entirely on Jupiter's willingness to serve as the solar system's punching bag, standing between civilization and cosmic annihilation. Jupiter's magnetic field. The death of Jupiter's most famous storm is happening before our eyes, and Juno has given us ringside seats to watch a cosmic legend fade away. Amy Simon from NASA's Goddard Space Flight Center has been tracking the Great Red Spot's decline using Hubble Space Telescope observations, documenting a shrinkage so dramatic it's rewriting our understanding of atmospheric longevity. The spot has contracted from 25,500 miles across in the late 1800s to just 10,250 miles today, less than half its historical size. Beginning in 2012, amateur astronomers noticed the shrinkage accelerating to an alarming 580 miles per year, transforming the storm from an oval to a circle as it literally starves to death. Yale PhD student Caleb Kevaney and his team have developed computer models showing that the Great Red Spot is essentially eating itself. Smaller storms that once fed it energy are becoming less frequent, leaving the giant hurricane to slowly consume its own substance like a cosmic Ouroboros. Their simulations predict the spot could shrink to nothing in approximately 2.6 Earth years, marking the end of a weather system older than human civilization. The implications go far beyond losing a famous landmark. The Great Red Spot plays a crucial role in Jupiter's atmospheric dynamics, and its disappearance could trigger changes throughout the planet's entire weather system. We're witnessing the transformation of Jupiter itself, watching a world that has remained essentially unchanged for centuries suddenly evolve before our eyes as its most iconic feature slowly fades into cosmic history. That's the incredible reality of Jupiter, a world so alien and violent that it challenges everything we thought we knew about planetary science. Juno's mission officially ends in September 2025, but the mysteries it has uncovered will keep scientists busy for decades. From dying storms to magnetic anomalies that defy physics, Jupiter continues to prove that our universe is far stranger and more terrifying than we ever imagined. What discovery shocked you the most? Drop your thoughts in the comments below. If you're fascinated by the cosmic mysteries lurking in our solar system, make sure to hit that subscribe button and ring the bell icon so you never miss another mind-blowing episode from Space Facts. Until next time, keep looking up. Imagine if something from another star system was racing toward our planet right now. On July 1, 2025, astronomers made a discovery that sent shockwaves through the scientific community, a mysterious object traveling at impossible speeds through our solar system. Meet 3I Atlas, the third confirmed visitor from interstellar space, and, honestly, it's unlike anything we've ever seen before. A rare visitor from deep space. What if I told you that right now, something ancient and mysterious is flying through our solar system at speeds that really defy imagination? This isn't science fiction, it's happening above our heads at this very moment. The object in question has been officially designated 3I Atlas, marking it as only the third confirmed interstellar visitor ever detected by human civilization. But, this cosmic wanderer is different from anything we've encountered before. Racing through space at an incredible 58 kilometers per second, it's moving faster than any previous interstellar object on record. What makes this discovery even more remarkable is that 3I Atlas was spotted while still incredibly far from Earth, giving scientists an unprecedented opportunity to study a visitor from beyond our solar system. Unlike typical asteroids or comets that orbit our sun, this mysterious traveler originated from somewhere else entirely. Possibly from a star system so distant that its light hasn't even reached us yet. The implications of this discovery are staggering, raising questions about what lies in the vast emptiness between stars and whether we're truly alone in the cosmos. As telescopes around the world track its every movement, one question echoes through observatories everywhere. What secrets does this ancient wanderer carry from the depths of interstellar space? The breaking discovery. Why does finding 3I Atlas represent one of the most significant astronomical discoveries of the decade? The answer lies in just how incredibly rare these interstellar visitors actually are. Before 2017, scientists had theorized about objects traveling between star systems, but none had ever been confirmed. The discovery of the third interstellar object in less than 8 years suggests something profound about our galaxy. It's filled with wandering worlds ejected from distant solar systems. 3I Atlas joins an exclusive club that includes only one I Oumuamua and two I Borisov, making it one of just 3 confirmed visitors from beyond our solar neighborhood. What makes this discovery particularly exciting is the timing. Unlike previous interstellar objects that were discovered when already leaving our solar system, 3I Atlas was spotted early enough for extensive study. The scientific community erupted with excitement because these objects represent actual samples of other star systems, carrying pristine materials that formed billions of years ago around distant suns. Each interstellar visitor provides a unique window into the formation and evolution of planetary systems throughout our galaxy. The rarity cannot be overstated. Statistically, we might expect to see one interstellar object every few years, yet we've now discovered 3 in rapid succession, suggesting our detection capabilities have finally reached the threshold necessary to spot these cosmic messengers regularly. The discovery story. How does one spot a cosmic needle in the haystack of space? The incredible detection story of 3I Atlas began in late June 2025, when the Asteroid Terrestrial Impact Last Alert System was conducting its routine sky surveys. The Atlas telescope in Rio Hurtado, Chile first captured this mysterious visitor on July 1, 2025, initially cataloging it with the mundane designation A11PL3Z. At first glance, it appeared to be just another faint moving object among millions tracked by automated systems. However, within 24 hours, something extraordinary became apparent. Follow-up observations revealed a faint coma and tail, immediately transforming the object from a potential asteroid into a confirmed comet. But the real surprise came when astronomers calculated its trajectory and velocity. Moving at an unprecedented 58 kilometers per second relative to our sun, 3I Atlas was clearly not gravitationally bound to our solar system. the Minor Planet Center quickly recognized the historic significance, officially designating it as 3I Atlas, the 3I prefix reserved exclusively for interstellar objects. Professional and amateur astronomers worldwide mobilized telescopes to capture this fleeting visitor, collecting 122 observations from 31 different observatories within days of discovery. The rapid identification and confirmation process showcased how modern astronomy has evolved to quickly recognize these rare cosmic visitors before they vanish back into the darkness of interstellar space forever. A stranger in our midst. So, what makes 3I Atlas so fundamentally different from everything else in our solar system? Well, the answer really lies in its absolutely mind-bending characteristics that, honestly, challenge our understanding of typical cosmic objects. First off, there's its incredible velocity. Racing through space at 58 kilometers per second, it's moving nearly twice as fast as the previous interstellar record holder, 2I Borisov. This extreme speed gives 3I Atlas a hyperbolic orbit with an eccentricity of 6.141, which means its path through our solar system appears almost perfectly straight rather than curved. The object's brightness has been measured at approximately magnitude 18, making it visible only through powerful telescopes. Yet its early activity suggests a nucleus diameter somewhere between 0.8 to 11 kilometers. What's particularly fascinating is its rotation period of 16.79 hours, determined by the Gran Telescopio Canarias, with brightness variations of only 0.2 magnitudes. This suggests a relatively spherical shape, and unlike typical solar system comets that only become active when approaching the sun, 3I Atlas began showing cometary activity while still 4.5 astronomical units away. That's much farther than normal. Its red spectral characteristics, with a slope of 18 plus or minus 4% per 1,000 angstroms, make it redder than most solar system comets. All these extreme properties mark 3I Atlas as a true alien in our cosmic neighborhood, carrying the unmistakable signature of its interstellar origins and, its billion-year journey through the galaxy. The predecessors. So, how did we go from never seeing interstellar objects to discovering 3 in less than a decade? The story actually begins with 1I Oumuamua, which made history in October 2017 as the first confirmed interstellar visitor. Discovered by the Pan-STARRS telescope in Hawaii, Oumuamua really baffled scientists with its unusual elongated shape and mysterious acceleration that just couldn't be explained by gravity alone. This cigar-shaped object, measuring roughly 400 meters long, showed no signs of cometary activity despite its strange behavior. Then came 2I Borisov in August 2019, discovered by amateur astronomer Gennady Borisov from Crimea. Unlike its predecessor, Borisov behaved like a typical comet with a visible tail and coma, providing scientists with the first opportunity to study pristine materials from another star system. Borisov moved at 32 kilometers per second and displayed the familiar characteristics of solar system comets, suggesting that similar formation processes occur around other stars. These discoveries really revolutionized our understanding of interstellar space, proving that the void between stars isn't empty but actually filled with wandering objects ejected from distant planetary systems. The rapid succession of discoveries, Oumuamua, then Borisov just 2 years later, and now 3I Atlas in 2025, suggests we've entered a new era of interstellar object detection. Each visitor has provided unique insights. Oumuamua challenged our preconceptions, Borisov confirmed familiar processes, and now 3I Atlas promises to reveal even more secrets about the galaxy's wandering population. The cosmic journey. So, where exactly is 3I Atlas headed, and what can we expect as it travels through our solar system? This interstellar wanderer is currently following a precisely calculated trajectory that will take it on a spectacular tour of our cosmic neighborhood. The comet will reach its closest approach to the Sun on October 29, 2025, passing at a safe distance of 1.36 astronomical units. That's roughly 203 million kilometers away. Thankfully for Earth, 3I Atlas will never approach closer than 1.8 AU to our planet, ensuring our world remains completely safe from this cosmic visitor. However, the journey gets more interesting when you consider the comet's path relative to other planets. Calculations show that 3I Atlas will pass relatively close to Mars during its solar system traverse, providing an unprecedented opportunity for spacecraft already in the Martian vicinity to observe an interstellar object up close. As the comet approaches the sun, solar heating will intensify its activity, potentially creating a spectacular tail visible to advanced ground-based telescopes. The James Webb Space Telescope is already preparing observing campaigns to study the comet's composition as it becomes more active. After its solar encounter, 3I Atlas will begin its exit from our solar system, accelerating back toward interstellar space on a trajectory that will carry it away from the sun forever. This entire journey, from discovery to solar passage to final departure, honestly represents a once-in-a-lifetime opportunity to study an object that has traveled through the galaxy for potentially billions of years. A scientific goldmine. Why are astronomers around the world calling 3I/Atlas the discovery of the century for interstellar research? Well, this cosmic visitor represents an unprecedented scientific opportunity that, combines perfect timing with revolutionary technology. Unlike previous interstellar objects that were discovered too late for comprehensive study, 3I/Atlas was spotted early enough for detailed observations throughout its entire solar system passage. The James Webb Space Telescope, Hubble Space Telescope, and ground-based observatories worldwide are coordinating the most ambitious interstellar object observation campaign in history. Scientists can study the comet's composition, structure, and behavior as solar heating gradually activates its surface, providing insights into materials formed around distant stars billions of years ago. Spectroscopic analysis has already revealed water ice and silicate grains in its coma, but researchers expect to discover much more as the comet approaches the sun. The object's red spectral characteristics suggest surface materials that have been altered by cosmic radiation over eons of interstellar travel. Advanced computer modeling can determine the comet's likely origin point in the galaxy, potentially identifying the star system from which it was ejected. This research extends far beyond simple curiosity. Studying interstellar objects helps scientists understand planetary formation processes throughout the galaxy, the frequency of planetary system disruption, and the chemical evolution of interstellar space. 3I/Atlas essentially serves as a traveling laboratory, bringing samples from distant cosmic environments directly to our solar system for analysis with our most sophisticated instruments. Unanswered questions. What fundamental mysteries about 3I Atlas continue to puzzle the world's leading astronomers? Despite intensive study, this interstellar visitor guards many of its secrets jealously, presenting challenges that push the boundaries of current scientific understanding. One of the most perplexing questions involves its exact size and internal structure. While estimates suggest a nucleus diameter between 0.8 to 11 kilometers, the active coma makes precise measurements extremely difficult, as distinguishing the solid nucleus from surrounding gas and dust requires sophisticated techniques. Its unusual red coloration raises questions about surface composition and the effects of billions of years of cosmic radiation exposure during its interstellar journey. Scientists are particularly puzzled by the comet's early activity at 4.5 astronomical units from the Sun, much farther than typical solar system comets begin showing signs of sublimation. This suggests either highly volatile surface materials or unusual internal heating mechanisms that remain unexplained. The object's rotation period of 16.79 hours with minimal brightness variations hints at a nearly spherical shape, but how this relates to its formation and evolutionary history remains unclear. Perhaps most intriguingly, determining its precise origin point in the galaxy requires complex calculations involving galactic motion over potentially billions of years. Researchers are also grappling with understanding how 3I Atlas maintained its structural integrity during its epic journey through interstellar space, surviving impacts from cosmic dust and radiation that should have gradually eroded its surface over geological timescales. The alien question. Could 3I Atlas represent evidence of artificial construction rather than natural formation? This controversial question has sparked intense debate within the astronomical community, particularly given the mysterious behavior of previous interstellar visitors. Professor Avi Loeb from Harvard University, who previously suggested that one Oumuamua might be an alien probe, has expressed interest in the unusual characteristics of 3I Atlas. Loeb points to the object's extreme velocity, early cometary activity, and red spectral signature as potentially anomalous features that warrant careful investigation. However, the vast majority of scientists favor natural explanations for 3I Atlas's properties. Unlike Oumuamua, which showed no cometary features despite mysterious acceleration, 3I Atlas behaves much more like 2I Borisov, displaying typical comet characteristics including a visible coma and tail. Its composition of water ice and silicate minerals matches what we'd expect from naturally formed comets in other star systems. The object's rotation period and brightness variations are consistent with a natural body shaped by billions of years of gravitational and thermal forces. Leading planetary scientists argue that the extreme properties of 3Y Atlas, its high velocity and early activity, can be explained by its formation in the outer regions of a distant planetary system and subsequent ejection through gravitational interactions with massive planets or stellar companions. While the possibility of artificial origins cannot be completely dismissed without comprehensive analysis, current evidence strongly supports 3I Atlas being a natural interstellar comet rather than technology from an advanced civilization. Dawn of a new era. How has 3I Atlas ushered in a revolutionary new chapter in astronomy and interstellar exploration? This discovery represents far more than just another cosmic visitor. It marks humanity's transition into an era where interstellar objects become regular subjects of scientific study, rather than once-in-a-lifetime anomalies. The Atlas Survey Network, with its 4 50-centimeter telescopes strategically positioned around the globe, has demonstrated that we now possess the technological capability to routinely detect these elusive visitors. Advanced sky surveys like Pan-STARRS, Catalina Sky Survey, and the upcoming Vera Rubin Observatory will dramatically increase our detection rates, potentially spotting several interstellar objects per year. This technological revolution extends beyond simple detection. Modern spectrometers, adaptive optic systems, and space-based telescopes allow unprecedented detailed study of these cosmic messengers. The coordination between 31 different observatories to track 3I Atlas showcases how global astronomical networks can mobilize to study rare phenomena. Future missions may even attempt to intercept interstellar objects with spacecraft, as proposed by the European Space Agency for rapid response interstellar visitor encounters. The implications extend to planetary defense, astrobiology, and our understanding of galactic evolution. 3I Atlas proves that we're entering an age where the study of other star systems will be revolutionized by analyzing actual samples delivered directly to our solar system, making every interstellar visitor a potential key to unlocking cosmic mysteries that have puzzled humanity for millennia. As 3I Atlas continues its ancient journey toward the sun, it carries with it the promise of revolutionary discoveries about our galaxy and our place within it. This remarkable visitor from interstellar space reminds us that we're part of a dynamic, interconnected cosmic community where worlds wander between the stars. For more incredible space discoveries that challenge everything we thought we knew, make sure to like, share, and subscribe to Space Facts, where the universe reveals its most astounding secrets.